Alright, so I want to do a review for inclined planes, statics, and friction. So, whoops, sorry about that. I don't know what's going on, but this is being a little goofy. Alright, so what I know is I have a ramp. The ramp is inclined. I'll do better than that. The ramp is inclined at 28 degrees. I have a trunk resting on it. It has W. The weight is made up of WY and WX. WX is trying to slide it down the ramp. The part of gravity that's trying to slide it down the ramp is called WX. WY is pushing into the ramp. The ramp is responding by exerting a force like that, called a normal force. And there's some friction, because gravity is trying to slide it down. If there is no friction, then it will slide down, but it tells me that it's resting there, so there has to be friction to keep it in place. Now, I know that that's 28 degrees because that's what it tells me, so this has to be 28. I know that weight is equal to mass times gravity, so before I can find WX or WY, I have to get weight. The mass was 16 kilograms. Gravity is 10. So my weight is 160 newtons. WY is this side here, so it's going to be adjacent to the 28 degree angle, so I'm going to say the cosine of 28 degrees times the hypotenuse of 160 is WY. So that's my 160 on the hypotenuse. So I multiplied the cosine of 28 times 160, I got 141.3 for WY. WX is this one here, so the sine of 28 degrees times the hypotenuse, W, would give me WX. So sine of 28 times 160 gives me WX. When I solved for that one, I got WX to be 75.1 newtons. So I've taken care of A and B. The normal force is going to balance WY. So the normal force is equal to WY, which is 141.3 newtons. So that's letter C as in cow. This was a B. This was A. Now I need to take care of friction. Well, friction is equal to WX. We already said that. They have to balance each other, because if they don't, then the object will slide down. Alright, and WX we just solved for 75.1 newtons. So that would be letter D. And letter E wants to know what mu is. Well, mu is friction over normal. And I was asked to solve for both of those, so that should be pretty easy. Friction was 75.1 newtons. Normal was 141.3. The newtons will cancel out. I'm going to divide 75.1 by 141.3, and I'm going to get 0.53 for my mu. So that one's done. Okay, now we want to look at the next one. It tells us that this sign has a mass of 610 kilograms, so the weight is mass times gravity. So this is a very heavy sign. 610 kilograms times 10 meters per second squared gives me a weight of 6,100 newtons. Alright, but I want to know this tension. These angles are equal, so the tensions will be equal. I know that the tension has a y component here and a y component here. It also has an x and an x. But all I really need to care about is what's going on with the y. So I have two y's that are acting straight up, and they have to balance the weight down. So y is going to be the weight of 6,100 newtons over 2. So that gives me 3,050 newtons. But that is not what the question asked me for. It didn't ask me what y was. It wants to know what this t is right here. So if this is a 26, this angle here has to be what, a 64? So I said the cosine of 64 degrees is equal to y over the hypotenuse t, or t is equal to y divided by cosine of 64. So y was 3,050. going to divide that by the cosine of 64. And when I did that, I got T to be 6,958 newtons. Okay. All right. Okay, so now I want to look at the sofa. I can't draw a sofa, so this is my sofa. It's being pushed across the floor like that, so that's the applied force. It's being pulled down with its weight. So that's 98 newtons. I'm sorry, 98 kilograms times 10 meters per second squared, which is 980 newtons. The normal force is pushing back up, and it's equal to the weight in this situation. If I'm pulling it to the right, friction will act to the left. It tells me it's at a constant speed, so if that's true, then the applied force has to equal the frictional force. Okay. Now, what I do know is that they gave me my mu. Mu is equal to 0.24 newtons, or 0.24, no newtons. So if mu is friction over normal, then mu times my normal should equal friction. Mu is 0.24. My normal is equal to my weight, 980 newtons. So I'm going to multiply 0.24 by 980 newtons to get my frictional force, and my frictional force is 235.2 newtons. And that's supposed to be an N there for newtons. Okay, it says place the correct value in all of the empty spaces. Assume the object is moving to the right at a constant velocity. So that tells me that all the forces have to add up to 0 because the net force is 0. So this thing has a mass of 15 kilograms, so 15 kilograms times 10 meters per second squared gives me my weight. So that's 150 newtons. This is Fy, and I'm going to find that by saying that Fy is equal to the sine of 45 degrees times the hypotenuse, which is 70. And that gives me 49.5 newtons. I have a 45, 45, 90 triangle, so this has to be the same size, 49.5 newtons, and I can prove that by taking the cosine of 45 degrees and multiplying it by 70 to give me Fx. All right, my F, force of friction, since it's going at a constant velocity, friction has to be equal but opposite to Fx, so that's 49.5. Now, I haven't done my normal force. Be careful. This is an upward force, this is an upward force. So the normal plus Fy has to balance the only downward force, which is weight. So the weight is 150 newtons. Fy we said was 49.5 newtons. So the normal force is going to be 100.5. Get mu by saying friction over normal. Friction we said was 49.5. Normal we just calculated to be 100.5. They're both in newtons, so that'll cancel. So if I take 49.5 and divide it by 100.5, I got my mu to be 0.49. Okay, so we want to look at a 12.2 crate, and that's dumb. It should say 12.2 kilogram crate is pulled across the floor with a constant velocity. I don't care how big it is, it just needs to be constant. So here's my crate. It has a weight. There's a normal force. I'm pulling it with a tension of 86 newtons. This angle here is 33 degrees. So I have an Fx and I have an Fy. I have friction opposing the motion, and friction has to equal Fx because it's not accelerating, so those forces have to be together. And the normal plus the Fy have to balance W because the ups have to balance the down. So first thing they want me to do is find the weight of the crate. Well, it's 12.2 kilograms. times gravity, which is 10 meters per second squared, which is 122 newtons. And then I need the horizontal component of the tension, so Fx is the cosine of 33 degrees times the 86 newtons. So if I multiply the cosine of 33 degrees times 86 newtons, I get 72.1 newtons. Fy is the sine of 33 degrees times 86 newtons. And when I did that, I got 75, no I did not, that's not true. I got 46.8 newtons. And then they want to know the frictional force. Well, frictional force is equal to Fx. So frictional force is going to be 72.1 newtons. The normal force, well that one's kind of a boogaboo, so the normal force is going to be the weight minus Fy. The weight is 122 newtons. Fy we just calculated to be 46.8 newtons. So the normal force is going to be W minus Fy, and when I subtracted those two, I got the normal force to be 75.2 newtons. Then, of course, the last thing it wants is mu. Well, mu is friction over normal. Friction we just calculated was 72.1 newtons. Normal we said was 75.2 newtons. So mu would be 0.96. Okay, we're going to stop there. Okay, we're on our last page now. And I said if an object is at rest or on an inclined plane, or an object is moving at a constant speed on an inclined plane, the following things must be true. The acceleration must be 0. There can be no acceleration. If friction is present, Wx must equal the amount of friction present. The normal force must be equal to Wy. If you're asked to calculate the coefficient of friction, mu, you must divide the force of friction by the force normal. Okay, then here's what's going on. Pulling that object like that. So I'm going to stop and mouse up so we can get all of that document and read it all. Okay, so that's what we have. So there's our diagram. And we want to talk about the weight must equal the normal force plus Fy, because these are both up and that's our only down. The upward forces must balance or equal the downward forces. The force to the right is Fx, while the force to the left is friction. The force to the right must equal friction to the left. The weight of the object must be calculated using the formula W equals mg. Oh, come on, cooperate. To determine Fx, the cosine of the angle must be used because this is Fx, so it's adjacent. To determine Fy, the sine must be used. And then in this particular case, the normal force does not equal the weight. Oh, can't spell. Does not. Because here we have a normal and a Fy, and the sum of those two forces equals the weight. Please study.